We are gonna do 7.1 and as much of 7.2 as we can today. And 7.1 is solving with substitution. So we are in our matrices unit. Matrices is a way to organize numbers. What we'll find later is we're gonna take equations like this and put it into a matrix. So we're gonna start by reminding ourselves that we can solve these algebraically. So humor me, help me solve this using substitution. How would I go about solving letter A?
Plus 9 y squared.
Okay, let's add that 9 to both sides first. So then we have what y equals 9.
And then 9 squared would be 31.
Well, we want to substitute this in for our y. So if we're going to put this in for our y,
I mean x.
good. So x squared equals 9. And then what's x going to equal? Good. Now, since we put the plus or minus in, we are in algebra. We have, or because we put the square root in, we've got to do plus or minus. So remember that this is just an algebra problem. It's not a geometry. We don't know real life if it's a positive or negative. I'm going to write most of my answers as ordered pairs as well. If you don't like this, don't do it. It's your notes. I don't really care. But I need you to recognize what we plugged in to get what we got. So in this case, we plugged in 9 for y, and that gave us both 3 and -3. So those are both of my answers to this algebraic problem. All right, let's do letter B. We'll do that one together too. Which equation do you want to get one of the variables by itself? First one, which do you want by itself? X, good. So we'll add that y to both sides. So we get x equals y plus 3. And then we do what? Substitute in. So I'm going to put, instead of x, I'm going to put y plus 3. Now, last period, we talked about this a lot, and they were like, do we need parentheses? Do we not need parentheses? I'm going to argue, since you're not multiplying anything by x, the parentheses is not necessarily more helpful or less helpful. I don't technically need it there because I don't have to remind myself to substitute or to distribute something else. I just replace x with y plus 3, and now I can go about my business combining like terms. I will remind you when we have a square, I would probably get everything to one side and then see if we can factor or quadratic formula or any of that. Alea.
You don't put the
Okay, let's add that y squared to both sides. Let's minus y from both sides, and let's minus 3 from both sides. And once everything cancels out of that left side and I'm left with 0, I am going to put the right side in order. So I'll go y squared plus 2y minus 3. Y squared plus 2y minus 3. Okay. And so now I'm going to factor that out. That's going to be a pretty easy factor. Y plus 3, y minus 1. And then so y is going to equal what?
-3.
Awesome, -3 and 1. Now, since we have 2 answers for y, we have to plug both of those into the first equation. Or truly, you can use that second equation. I just feel like that's a lot more work, especially if I have the y. I think it's easier to just plug it into the first equation right here. And we'll plug in -3 and see what x we get out. We'll plug in 1 and see what kind of x we get out. So we'll do -3 plus 3, and that equals 0. And then we'll do 1 plus 3, and that equals 4. If you're good, you're welcome to just leave x as 0 and 4, y is -3 and 1. One thing that I like to do in this case is remind myself what I did to get the other number. So the two numbers that go together, -3 and 0 go together, but 0 is my x, so it has to go first. Same thing with the other one. I've got 1 and 4, they go together, but 4 has to go first because it's my x and 1 is my y, so it goes second.
Do we ever have to write it like that?
I mean, I hate saying never or always, but will I, like, if I gave you a substitution problem on a test, I probably won't say it must be written in ordered pair form.
So we just need to have the full line.
Yep, as long as you understand how I got from here to here, it doesn't really matter to me. Also, will there be a lot of substitution on your next test? Probably nothing, because it's a matrix unit. And so we're just practicing this a little bit, but most of what we're doing is the matrix stuff. Okay, why don't you try the next 2 on your own? Can you do that? Try the next 2 on your own. Maybe I should take attendance so Mr. Creedy doesn't call.
Plus Y.
Plus 6y.
Plus.
That's a 6. Let's see if that makes it easy. Sorry, I'm coming. Right, my question to you, is that a true sentence?
No,
What do we have then if it's not true?
no,
No.
No solution, but
So what about next one?
it doesn't,
Okay.
It's not in-
there's nothing for either variable that we could plug in that would make this work. All right, I'll leave that up for a second. Go ahead and start D without me. I'll join you in a second. Yep, do the next one. All right, check your answer D when you get it, when you get a check, when you get a second. Get the same thing that I do. Hey, everybody go to substitution? It's a nice little algebra 1 review, isn't it? Okay, let's go practice some elimination. Oh yeah, Alea first.
The other equation, what did you do? I can't.
I didn't do anything with the other equation.
Okay, why did you get it?
I used the second equation right there, y equals 1 minus x, just because I thought that was easiest. Technically, I don't have to touch this equation if I don't want to.
So how did you get -2?
I got -2 because my x was 3, and so I plugged it into this equation right here and did.
Oh, okay. I
1
forgot
minus.
that's what you did.
You gotta plug it back in. All right, moving on to elimination. Remember this one, we've got to eliminate one of the variables, I don't care which. What should I do? What should I multiply by? The bottom one by 2? Good, I like to do -2. Somebody last class was like multiply by 2 and then subtract them. That's totally fine with me. I tend to forget whether I'm adding or subtracting, so I usually like to get opposite signs. So I'm gonna multiply the bottom by -2, so I get -2x plus 4y equals 10. That way I know all my signs are how they're supposed to be. And then when I combine it with the first equation, then I just like add the columns up, or I do whatever the sign is. So -2x and 2x, that cancels out. 4y plus y is gonna be 5y, and then 10 plus 10 is 20. Y equals 4. And then on that one, you can plug it into the first equation, you can plug it into the second equation, or you can plug it into the equation you made by multiplying by 2 or -2. I don't mind. Just do whatever you think is easiest. So I'm gonna go into my first equation. I will do 2x plus y equals 10, and that y is 4. And then I'll just solve for that. I get x equals 3. And again, if I wanted an order pair, I'd go 3, 4. Okay, I think there are 2 more elimination, one on this side, one on the other side. Go ahead and try letter B and C on your own. I didn't even do that. I didn't even understand, you just got real exciting. I think I did that right. Okay. I must have had last class, I lost my negative, so don't lose your negative. All right, once you're done with B, make sure that your work's the same as mine, and then flip to the back, and then I'll join you on the back side in a second. Was that a true statement? So you can say.
Can you go back into the- Okay.
Got it.
See no solution.
Not, no solution. I end up getting 0 equals 0. Is that what you get? Like everything kind of crosses out.
Yeah.
So when 0 equals 0, that actually is a true statement. So that means all reals is your answer, or often in Algebra 1, we call it infinitely many solutions, whatever makes you happy, but that is our answer instead. So it's not no solution, it's quite the opposite. It's everything's a solution. Everything will make it true. All right, I've got one more like this before we do new stuff. This I would do, I'd probably do substitution on this one. It just says solve, it doesn't tell us why. When I get to number 3, I am gonna be annoying. I'm gonna make us solve it all out by hand. And then I'm gonna show you that immediately you can just put it right in the calculator. But I like to do the hard part first, not the easy and then the hard. That's always, I think, painful. So we'll do the little bit of a hard part first, just to prove to yourself that you can do this by hand. I know it's annoying, but you can do it by hand. Okay, so when I go to solve this first one, I'm gonna do substitution because I don't have a plus or minus for that first equation. It's gonna come down, I don't really care. Do you want to solve for X or Y? Which one do you want by itself? Sure, X by itself. So I'm gonna divide by Y. So X is gonna be equal to 300 over Y. So I'm going to plug that in for my X in my first equation. So I get 2X plus 2Y equals 100. Now, when we go to do this in the calculator, I would probably right this minute, put this in the calculator. You don't need to simplify, you don't need to move anything around. If I'm ever gonna put in the calculator, I like to put it in right away, immediately put it in the calculator, but we're not gonna do that yet. But when we do, we will put it in for Y1, Y2. Yes. What we're gonna do instead is pretend like we do not have a graphing calculator, we can't solve to find the intersections, so instead we're gonna simplify, okay? So I'm gonna start by distributing that 2, so now instead of 300 over Y, I get 600 over Y plus 2Y equals 100. Don't multiply, you only multiply it on top, not on bottom, because that's like 2 over 1. Now, I don't like that Y as a fraction, do you like that? No, so let's multiply everything by Y to get rid of it. So 600 over Y times Y, 2Y times Y, 100 times Y. Instead of having 600 over Y, now I just get 600. And instead of 2Y, I now get 2Y squared. Instead of just 100, I now get 100Y. Now, this looks like a quadratic. Let's move everything to one side, see if we can factor it out. I'm gonna put the 2Y in front, I'm gonna put that minus 100Y in the middle, and then I'll put my 600 at the very end. All that equals 0. Now I can do one more thing before I even start to think about factoring. What can I do? Divide everything by 2. So if I divide everything by 2, and the reason I can divide by 2 is it's an equation, not just an expression. Okay, so now I'm starting to think about numbers that multiply to be 300. I can think of 1 and 300, but that will never add to be negative 50. I can think of 3 and 100, but that won't add to be 50. What else? 20 and 30. $25 and what?
Yeah,
No, I said 45.
Oh, 45, 25 and what? 25 and 20? 20 and 30? Yeah, those will those multiply to 300? 600, there you go, yeah. I don't think that's 300. So I like racked my brain. I'm gonna be honest, I don't know if there's anything that's gonna work. What's our option if nothing works? Quadratic formula, so let's go ahead and do that. Are you mad? Just quadratic formula, it's not that bad. Oh, wait, like we're just done now. So sorry, I didn't mean to be a day ruiner.
It's okay.
Now, I would probably need a little bit of a calculator to do some basic stuff, like, I'm gonna be honest, 50 squared, I don't know that off the top of my head. Actually, I probably should, that's kind of embarrassing.
It's okay, Miss White.
Same thing here, that's probably embarrassing, I plugged that in last period, it's a little embarrassing.
It's okay.
I have a whole math degree though, so I should be able to do 50 squared in my head. Cause 5 squared is 25, and then there's 2 extra zeros, so that's where we get 2,500.
At least you know now.
I do know now, but I did embarrassingly just put it in. Same thing here, yes, I could probably put all this in the calculator, that would be 1,300. And then I do know 1,300, the easiest way to factor that is it has a multiple of 100, so I'll just take that 10 out. But then I will say 50 and 10 and 2 both have a common factor of 2. So I can take a 2 out of all of them. So 25, 5, and then 1. So my final answer here would be 25 plus or minus 5 root 13. Would you say? Okay. It's an annoying, it's just a decimal. Now, what we're gonna do is go back and plug it into the calculator. So if this was a calculator test, and I'm gonna be honest, we're gonna have word problems that are gonna end up looking like this as we move on to this unit, which is why I wanted to preview it right now. If I give you a calculator, if we know we can use our calculator, all that fun stuff, I would from the beginning have plugged this in. I would have taken this and made that my Y1. And I would have taken this and made that my Y2. So let's get our calculators out. Let's go ahead and plug that in. Doing all of that work. We'll have to play with our mode. Yep. I mean, our window. We'll have to play with our window a little bit.
Are we supposed to make it bigger really?
It doesn't matter because we're not doing any trig. So if we were doing sine or cosine, it would matter. We don't have any sine or cosine, so it won't matter. So I'm gonna do 2 parentheses 300 divided by x, because that's my only variable, plus 2x. And then my Y2 is 100. Now, it's been a while since we played with our window. What do I know that my Y max must be higher than?
100.
Must be higher than 100. So I'm probably gonna put in 200 just so I can see enough of my graph. Is there a bug? Do you need help?
I didn't push it away.
It's that same one that's why it's.
It's probably the same one. We should name him. Because he made it in the back.
That's why it's on call.
Miss Ludington's classroom had bugs yesterday. Did you hear about that?
Yeah.
What kind of bug?
They were like flying around. They like moved the classroom.
Oh,
They think they were just flying ants, but I'm like, just flying ants.
and
That's a no for me. All right. Where was I?
we gotta shut the doors, make sure they can't be here.
Okay, so we gotta make sure our window is at least more than 200. I put my X max to 50 just because I wanted to make sure that I had enough visual. I should get 2 answers here because when we solved it with quadratic formula, we had a plus and a minus, so we should have 2 answers. I don't need anything for my X min or for my Y min, so I just put zeros there. So go ahead and graph those. Now that I graphed these, I see that I got 2 answers, so let's go find those points of intersection. So second, trace, intersect. It's been a while since we've done that, but you guys know how to do that. So one of my answers for Y is going to be 6.97. I'll round it up to 7. And then my other answer, do my intersect on the other side,
43.
43, perfect. So it could be 7, it could be 43. How do we go about finding the X values now?
Zeros? Makes sense.
Nope. I actually am done looking at the graph once I find these numbers. Plug it in. And I actually think that purple thing I have right above it is a really easy thing to plug into. So I'm gonna do 300 divided by 7 and 300 divided by 43 and see what we get. I just go back to the normal mode of my calculator. 300 divided by 7 is 42.85, which is 43. And I'm also gonna do 300 divided by 43, which should be the exact same thing as what we just got. And I get about 7. So both my X and my Y are 7 and 43. We just gotta make sure that they're in opposite orders. So if I had a 43 as an X, then 7 was my Y, and if I had 7 as my X, then 43 as my Y.
Will it always be like that? Or this one just worked out?
This one worked out that way. I will tell you, oftentimes it's the same number. Oftentimes it's like a square. We're gonna do a lot of like, find the maximum perimeter if the area is blah, 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 or find the, or the minimum perimeter, find the maximum area if the perimeter is blah, blah, blah. and often it's a square. This is basically just a rectangle, and it's like, okay, if my length is like 43, then my width is small, it's 7. And if my width is long, like 43, then my width would be 7. So it's just like, is it a rectangle that's like short and fat, or is it a rectangle that's tall and skinny? Okay, that's the end of 7.1. We're gonna get into 7.2 again, because the more I can teach you in person, the less you have to do on a video on Monday. I will take a video during C period tomorrow though, so I'll try and post it tomorrow, so you don't have to do it on Monday. But when I see you on Tuesday, it's just gotta be done. That's just gonna be the arrangement that we do. So we are into our matrix units right now. And I want you to actually flip your paper over, and we actually don't need a calculator. I'm gonna do plenty of calculator stuff later, but right now we're not gonna do any calculator stuff. If you look at what you can see right now is just a bunch of vocab words. If you flip over to the next page, this is what I mean when I say matrices. These are matrices. Matrices is the plural of a matrix. So A is a matrix, B is a matrix, C is a matrix, D is a matrix. Bless you. All a matrix is a way to organize or arrange numbers. It's just a way that we organize and arrange numbers, okay? I feel like I had another word in there, so let me just double check on my answer key really quick that I give you the exact right definition. Oh, the word I was missing was rectangular, which I think is a good word to have. A matrix is a rectangular arrangement, or if you like the word organization, you can use that word instead. It's a rectangular arrangement or organization of numbers. So a matrix is just like how we write it. An equation is a way that we organize numbers, but we use variables and operation signs. Matrices doesn't have any of those. It's just numbers in a rectangle pattern. The dimensions of a matrix is the size of the matrix. And we use brackets and 2 numbers with an X between it. It's like if you do like any like, I don't know if building is the right word, but like if you've done any like handiwork or even like arts and crafts, if you're building something, we get like 4x6s, it's like a type of wood you could get. Or if you're like getting like a canvas or a piece of paper, like a normal piece of paper is an 8.5 by 11, right? That's just the dimension of it. Same thing we do with matrices. Now, because I'm very old enough to know, yeah, just like a very common fact. Now we do our rows by our columns, okay? So we do number of rows by number of columns. Can you show me with your hand what are rows? Good, horizontal rows. What are columns? Vertical, good. I sometimes forget, so I have to remember like on a building or in a house, columns like go from the ceiling to the floor, so they're vertical. So it's number of rows by number of columns, okay? Square matrices have the same dimensions, which means that the number of rows is equal to the number of columns. Number of rows equals number of columns. Just making sure I'm getting all the same answers I did last class. Okay, perfect. And then the last one before we go and do some of these, entry or element is each number. Oh, equal. Is each number in your matrix. So if we're dealing with one single number in a matrix, then I would say that's the element or that's an entry. Okay. We'll hit more of this vocab as it comes up, but that's enough for us to get started. So let's start seeing how matrices work. Okay. What I want to do is flip our paper over. We've got A, B, C, D. I showed you that a second ago. Let's start by doing the dimensions for A, B, C, and D. Okay. So dimension for A, how many rows are in A? Good. How many columns are in A? 2. So that's a 2 by 2 matrix. So I read that 2 by 2. What about letter B? How many rows are in letter B? How many columns are in letter B? Good. It's another 2 by 2 matrix. Wait a second. Both of them are 2 rows, 2 columns. Are those square matrices? Yeah. Is their number of row the same as the number of columns? Awesome, so those are squares. What about letter C? How many rows are here? How many columns are here? Is letter C also a square matrix? Yeah, the definition is just same number of rows, same number of columns. 100 by 100 would be a square matrix. So I'm actually gonna write that down. I'm gonna label all these and I'm gonna say squares. Now, letter D is not a square matrix. What's its dimension? 2 by 3, good. Okay. I will eventually show you how to do matrix work in the calculator, but especially when we're doing with small enough ones like this, we can do these by hand. So we're gonna start by doing some addition and maybe even some multiplication before we leave today. That would be awesome, okay? When you are adding or subtracting matrices, I do encourage you to rewrite them. So I'm gonna rewrite A and B. And then we just add the elements that are in the same spot with the element in the other matrix in the same spot. So, okay, let's look at that. So I'm gonna have 1, -2, 3, 5. I just copied matrix A. Now I'm gonna copy matrix B so I can add them together. I'm gonna start by looking at the elements that are in like the top left hand. We'll start top left hand. I'm gonna add those two together. Now, if this on the outside was a minus, we'd minus them together. But when you add and subtract, you just look where they are in the same spot and you add those or subtract those, combine those together. So in my new matrix, the top left is gonna be the combination of the first top left, which is 1, plus the second top left, which is 6. So that's just gonna be 7. Okay? I generally go across the top and then I loop down to the next row. As long as you are consistent, I don't really care what order you go in. So I'm gonna go top right now. -2 plus 3 is gonna be 1. I'm gonna go bottom left now. 3 plus 0 is 3. And then I'm gonna go bottom right and do 5 plus -4 is 1. Okay. One thing to note, you can only add and subtract if the matrices have the same dimension. So this worked out nicely because there's only a top right and a top left and a bottom right and a bottom left. If there's anything extra, we can't do that. So addition and subtraction must have same dimension. That's not true for multiply. So when we get to multiply, I'll explain that rule in a second. All right. Now, letter B says A plus 2B. What do you think that 2 in front of that B is going to do? Multiply all of the elements by 2. So let's do it and then I'll explain the vocab word behind that. I'm gonna rewrite A, so I'm gonna write 1, -2, 3, 5 again. And you can do one of two things. You can write your 2 on the outside and then write B. And then your next step, you can multiply that all the way through. Or you can just look at B and multiply 2 as you rewrite it, which is probably what I'm gonna do. So 2 times 6 is going to be 12. 2 times 3 is gonna be 6. 2 times 0 is still 0. And 2 times -4 is going to be -8. So I multiplied everything by 2 before I wrote it down. And then now I'm gonna do my same matrix addition like we did above. I'm gonna keep my little color coordinating going, but I'm gonna be quiet in case you wanna try it on your own.
So what we just did was how does it correlate with that?
Substitution elimination. We are going to write those kind of equations in matrix form and be able to solve them as matrices, not as substitution and elimination.
So how can we do C?
Give me 1 second, because I think you're just a little too fast. I'm gonna argue you can't. Can you decide why we can't? No, don't tell me yet, don't tell me yet.
Okay, yep, I do.
It's way too fast today, chill out. All right, or maybe I am just very slow, which also might be the case. I'm just like a little off today. Do you guys ever have those days? Like nothing's wrong. I'm not that tired. I'm not sick. Something is a little off.
Yeah. It's called school air.
School air. I think it's called April senior year. And on a rainy day where we all rather would be.
Yeah, my hair's here and you get here. And the end of the day, you can look like you just. Every day it's called school air. School air.
School just really puts you through it. You're like, why do I look terrible? I didn't do anything.
Oh, I.
Okay. Luke, you may go to the bathroom. Okay, so Sophia already kind of previewed that the next one's not gonna work. Sophia, why is the next one not gonna work?
They don't have the same dimensions.
They do not have the same dimension. So when I go up here and look, A has a dimension of 2 by 2 and D has a dimension of 2 by 3. Now, let's say I forgot that they need to have the same dimension. I could start this just like we started the other one. I can do 2 times A. So I get 2, -4, 6, 10. And then I set up my D and I've got that 2, -1, 3, 5, 1, 4. Then I start going to add them together. I go, okay, 2 + 2, cool. -4 + -1, awesome. Wait, now I don't have anything to add to 3. The minute I know I have nothing to add to it, that means I can't do it. And I just on my notes just wrote no. You can't do that. This is not possible. And you don't even have to write all that stuff that I wrote out before. You can, like Sophia noticed earlier, you can just say, oh, I know that it's not going to work out. And I might even write must have same dimension. Right. Awesome. This is where we stopped last period, but I'm going to keep going with you because multiplying isn't hard, but it's going to be way more fun and way easier when we do it together than when you're going to try and learn on the video. Are you guys ready to multiply? Okay. So, oh wait, before we do that, let's go back up to our vocab. There's a word scalar that I didn't do. That's that number 2 that we just did. Scalar is a real number. It's not a matrix. And what we just did when we did 2b and 2a, that's what we call scalar multiplication. And when we do scalar multiplication, you multiply the scalar by every element, by every number in the matrix. Multiply scalar, or I guess I'll say multiply elements by scalar. Maybe every element by the scalar. Multiply every element by the scalar. Okay. Okay, so now when we come down to multiplication, they don't have to have the same dimension. They have to have something in common though. The number of columns in the first matrix must be the same as the number of rows in the second matrix. Okay. So I'm gonna write that right here. I guess this is all multiply. So when we do multiplication, number of columns in the first matrix must equal the number of rows in the second matrix. Number of columns in the first needs to match number of rows in the second. Now, I'm going to show you that that's not necessarily something that you have to think in your head. We're going to use the dimensions, okay? So let's look at dimensions of A and B. What was it? The dimensions of letter A? 2 by 2. And what was it for letter B? 2 by 2. Okay. The thing that must match are the 2 numbers in the middle. So the second number is the number of columns. So the second number for the first matrix and the first number for the second matrix. Those 2 numbers in the middle should match. These match, so this is good. We can do this multiplication. And so we're going to work it out now, okay? Go ahead and rewrite A and B next to each other so that we can do this multiplication. 1, -2, 3, 5. 6, 3, 0, -4. In order to get the first row, first column, we're going to take the first row of the first matrix and the first column of the second matrix. To get first row, first column, we're gonna do first row of the first one times first row of the second one. And we're gonna multiply the two numbers that are in the same spot. So we're gonna multiply, I wouldn't do this circling on yours, but just so you can see what I'm doing. 1 times 6 plus -2 times 0. Okay, 1 times 6, and I'm even gonna write it out like that, plus -2 times 0. Now, when you do this, you can do that all in your head on the first step, but since we're learning, I'm trying to explain it very slowly, okay? So I'm doing 1 times 6 plus -2 times 0, okay? Now we're gonna get the first row, the second column. So I'm gonna multiply by the first row and the second column. You guys okay with that? So now I'm gonna do 1 times 3 plus -2 times -4.
So basically it's row times column.
Row times column, row times column, row times column. And we're only doing the rows in the first one and we're only doing columns in the second one. Bless you.
Do the same thing with mine.
We're gonna do the same thing on the bottom. So now to find the bottom left one, we're gonna do the bottom row and the left column. You guys kind of finding that pattern that we're doing? So 3 times 0 plus 5 times -4. And then to get the bottom right one, we're gonna do the bottom and the right row, or the bottom and the second column, bottom row, second column.
Is that supposed to be 6?
Is what's supposed to be 6, maybe this one right here.
Wait, how did you get the one at the bottom?
How I get that one?
Yeah.
That is, that's the blue highlight, it's the bottom row and then the left column, which is at 6 and 0. So I multiplied 3 times 6 and 5 times 0.
So 3
Oh.
times 6. Yeah.
So that should be 0 instead of -4. Is that what you were saying?
Oh.
This should be 0. No, I think I messed that all up. Oh, I hate this.
3 times 6.
3 times 6, 5 times 0. I'm so sorry, guys. I hate when I'm trying like really hard to be careful and then I'm like, I just screwed that all up. That was all wrong. I'm so glad we're all here to figure it out. 3 times 6 plus 5 times 0. And then now we're gonna do second row, second column. And so I'm gonna do 3 times 3 and 5 times -4. It's not difficult math, but it's easy to mess up just like I did. Didn't mean to make a mistake like that though. Okay. So let's actually do those out. So 1 times 6 and then plus -2. That's gonna end up being 4. 1 times 3 plus -8 is gonna be -5. 16 or 18 plus 0 is gonna be 18, and then 9 plus -20 is gonna be -11. So my final answer is this. Sheesh is right. We're gonna end up having to do a longer one on the video, but was this a good enough of a start for you guys? Okay, I'm glad we could at least get one of them all together. Okay, the video for 7-2 will happen after I teach it to C period tomorrow. You have 7-1 that you can complete. I'll ask that that's due by Tuesday as well. 7-2, we probably can push back a day, just depending on how everything's going. So let me turn this off and put it online. What's up?